So, hello students, I hope you all are good. And in today's operating system lecture, we will discuss about the numerical problems of shortest job first. Shortest job first जो हमने पहले जिसकी introduction की थी. We have discussed the introduction of shortest job first, its types, and today we will discuss the numerical problems of shortest job first so that it will become clear to all of you. So first of all, just take a quick review on shortest job first scheduling algorithm. It means the job with the shortest burst time will execute first. As its name shows, the job with the shortest burst time, CPU burst time, कि वो जो जिसका सबसे छोटा टाइम होगा, that is called as shortest job first scheduling algorithm. अब ये टू टाइप्स की होती है, वन इज प्रिमिटिव एंड अदर इज नॉन प्रिमिटिव. नॉन प्रिमिटिव मीन्स अगर किसी जॉब को एक बार सीपीयू एलोकेट हो गया एंड इन अ क्यू कोई भी नई जॉब आई जिसका बस टाइम छोटा है, लेकिन नॉन प्रिम्प्ट नहीं होगा प्रोसेस, क्योंकि वो प्रोसेस कंटिन्यू किस में रन होगा, सिस्टम में रन होगा. एंड प्रिम्प्टिव मीन्स कि अगर कोई प्रोसेस अराइव हुआ है जिसका बस टाइम छोटा है रिमेनिंग टाइम से, करंट एग्जीक्यूटिंग प्रोसेस के रिमेनिंग टाइम से, सो जो करंट एग्जीक्यूटिंग प्रोसेस है वो प्रिम्प्ट हो जाएगा. एंड दिस इज ऑल्सो नोन एज शॉर्टेस्ट रिमेनिंग टाइम फर्स्ट. जो शॉर्टेस्ट ऑफ फर्स्ट है, इट इज वेरी वेरी इंपॉर्टेंट. इट गिव्स मिनिमम एवरेज टाइम as compared to first come first serve. It gives a less waiting time, average waiting time. So now we will discuss the numerical problems of non preemptive shortest job first and preemptive job shortest job first. See, here in this example, four processes are there: P1, P2, P3 and P4. Four processes are there. Its arrival time is given in this diagram, that is 0, 2, 4, 5. Means at point 0, which process comes first? Process P1 comes first. और दो 2 units पे कौन सा process आया pool में? P2. Then at 4 units P3 process comes, and at 5 units P4 process comes, and their burst time is given 7414. Now we have to solve this problem with the help of shortest job first algorithm. And one more thing is there, but we have to do, we have to see the bus time of each process. We have to see the bus time. Now see, the bus time of process P3 is smaller as compared to P1, P2 and P4. But zero time पे अभी सिर्फ कौन सा process था queue में? Process P1. At time 0, which process is there in queue? Only process P1 is there. So जो गैंट चार्ट बनेगा उसमें जो सबसे पहले जीरो टाइम पे, जीरो यूनिट्स पे जो सीपीयू एलोकेट होगा, दैट विल बी टू P1 प्रोसेस. CPU is allocated to P1 process. Now what happened? 2 units तक P1 process execute होगा. At 2 unit P2 process arrives. Now there are two things to be noted here. One is P1 process is executing, and that is executing for 2 units. That is executing for 2 units. So remaining time of P1 becomes 5. 5 units क्या रह जाएगा इसका remaining time. And in the meantime, P2 arrives, and bus time of P2 is 4, which is smaller than the 5, that is remaining time of P1. But because it is non-preemptive algorithm, ये non-preemptive algorithm है, तो इसमें क्या रहेगा, P1 कंटिन्यू रन होता रहेगा till its execution completed. That's why इस डायग्राम में जो रिप्रेजेंट किया गया है, P1 process after arriving of P2 doesn't get preempted from the CPU. P1 process continues its execution till the 7 units. 7 units तक जो process run हो रहा है, that is called P1 process, because it is non-preemptive algorithm. Now 7 पे तीनों प्रोसेस अराइव हो चुके हैं. P2, next is P3 and next is P4. But the bus time is smaller for which process? Because तीनों प्रोसेस अब क्यों में इकट्ठे एक साथ simultaneous आ चुके हैं, and we have to compare now 3 processes. At time 0, no process was there for the comparison of bus time. So now compare these three processes. P2 is having 4 bus time, P3 is having 1 bus time, and P4 is having 4 bus time. So which process is smaller bus time? That is P3. So next CPU किसे allocate होगा? P3 को allocate होगा. So CPU is allocated to P3 process at 7 unit, because till 7 unit P1 process is executing. Now 7 to 8 1 unit के लिए which process is running in the CPU? P3 process is running. Now next is the turn. Next we do comparison between which two processes? P2 having 4 unit of time and P4 having 4 unit of time. Both have equal both have what? Equal bus time. Both have equal bus time. But what happened here? We have to select P2. अगर दो processes का bus time same होता है तो किसे इस time run करना है? That depends on their arrival time. Which process arrives first? So which process arrives first out of P2 and P4? P2 process arrive first. So P2 will execute till 4 seconds. 8 to 12 P2 will execute, and then 12 to 16 which process will execute? Process P4. So this is the Gantt chart for this problem. So by this chart, we are able to calculate the waiting time of each process. Now waiting time of process P1. P1 process जैसे ही आया उसे 0 time पे CPU मिल गया. At that time no process was there in the queue. So its waiting time is 0. That process doesn't have to wait for the CPU. Now P2 waiting time. What is the P2 will come at 2 units, and the CPU is allocated to P2 at 8 units. By this Gantt chart, we are able to see P2 gets process 2 gets CPU at 8 units, and it comes at 2 units. So the waiting time is 8 minus 2, that is 6 units. So the waiting time of P2 is 6 units. Now P3 waiting time. P3 comes at 4. Arrival time of P3 is 4 units. And it gets CPU at 7. So its waiting time is 3 units. So waiting time of P3 is equal to 3 units. And last, what is the waiting time of P4? P4 comes at 5 and it gets CPU at 12. So 12 minus 5. 12 minus 5 is equal to 12 minus 5 is equal to 7 units. At 7 units means 7 unit is the waiting time for process P4. Now we have to calculate the average waiting time for this problem, and average waiting time is calculated by the total sum of all the waiting times divided by total number of processes. So sum of all the waiting times, 0 plus 6 plus 3 plus 7, for this unit for this problem. So this is called shortest job first, non-preemptive shortest job first. Here by this example, it is clear to all of you that what is non-preemptive. See, जब P1 को पहले process को CPU मिल गया है, that time no process was there in the queue. So its waiting time is 0. That means its waiting time is 0. Now P4 comes at 5 and it gets CPU at 7. So its waiting time is 3 units. That means its waiting time is 3 units. Now so that process continuously using the CPU. So it will not be preempted. ये preempt नहीं होगा. So this is the example of non-preemptive shortest job first algorithm. This is the example of non-preemptive shortest job first algorithm. So now comes on preemptive shortest job first algorithm. This is the other example of preemptive shortest job, and it is also called shortest remaining time first. This algorithm is also called shortest remaining time first. So what happened in this algorithm? See, there are 4 processes and the bus time is given in this. Same problem is there which is of non-preemptive. Now what happened? सी पहले P1 प्रोसेस को CPU एलोकेट हो जाएगा, 2 मिलीसेकंड के लिए P1 प्रोसेस चलेगा। अब जो चीज हमने पहले डिस्कस की थी सेम नॉन प्रिमिटिव के केस में, हियर वी विल डिस्कस द सेम थिंग। आफ्टर 2 milliseconds remaining time for P1 is 5। P1 का रिमेनिंग टाइम कितना रह गया, 5 मिलीसेकेंड्स। एंड P2 2 पे आ चुका है, और P2 का टाइम क्या है, नाउ बस टाइम फॉर P2 is equal to 4। Now which one is smaller, 4 or 5? 4 is smaller। तो P1 जो है वो CPU से निकल जाएगा, प्रिम्प्ट हो जाएगा, और CPU किसे एलोकेट हो जाएगा, अब P2 को एलोकेट हो जाएगा। सो P2 प्रोसेस गेट्स द CPU एट 2 पे किसको CPU मिल गया, P2 प्रोसेस को। Now P2 process continue running। अभी see by this which we write on the screen, we are able to So now what happens, out of these three processes, which processes जो हमने comparison किया, P1, P, P2 and P3. Now P3 have the smallest burst time, P3 have smallest burst time, that is 1 unit। See, P1 का remaining time कितना रह गया था, P1 का remaining time रह गया था 5 units, and P2 का remaining time रह गया था 2 units, and उसी टाइम 4 पे P3 आ गया, और P3 का क्या है, 1 है। तो द शॉर्टेस्ट प्रोसेस इज 1। सो शॉर्टेस्ट प्रोसेस इज 1, तो CPU will be acquired by P3। तो at 4 units P3 will get start executing in the CPU, and it will execute it till 5 because its execution time is 5, its CPU utilization time is 5। now at 5 पे हमारे पास 3 प्रोसेसेस हैं। at time 5, see, at time 5 we have 3 processes। one is P1 having 5 unit of time remaining, next is P2 having 2 units of time remaining, and next is P3 having 4 unit of times, out of which P2 is smaller. So which process will come next, P2? At 5 P2 come next, and for 2 milliseconds, for 2 units it will acquire CPU and it gets executed। and at 7, out of P1 and P4, sorry, P4 is there, at 7 P4 will get, because P4's execution time burst time is smaller than the P1, so it will take the CPU at 7 until 11 it will execute in the CPU, and at 11 P1 will completed its execution, because already for 2 seconds it has completed its execution, and remaining 5 seconds it will complete now for 11 to 16। so now we will calculate the average waiting time for each process। so average waiting time for process P1, see, in the starting 0 पे P1 आया, उसको 0 पे CPU allocate हो गया, बट वो 2 milliseconds के लिए रन हुआ। उसके बाद उसको कितना वेट करना पड़ा, 11 minus 2, 11 पे उसको allocate हुआ, and minus 2, so 9 units process P1 will wait। now P2's waiting time is P2 waiting time, P2 come at 2, 2 पे आया, 2 पे उसको CPU मिल गया, कोई भी वेटिंग टाइम नहीं है, बट वो 4 तक रन होके प्रिम्प्ट हो गया CPU से, एंड एट 5 उसे किस पे मिला CPU, 5 पे, तो 5 minus 4, 5 minus 4, its waiting time is 1। and third waiting time of P3, P3 कितने पे आया, 4 milliseconds पे आया, और उसको आते ही CPU मिल गया, और उसने अपनी एग्जीक्यूशन कंप्लीट कर ली। so waiting time of P3 is equal to 0। and next P4, P4 waiting time is, P4 comes at 5 and it will acquire CPU at 7, so its waiting time is 7 minus, its waiting time is 7 minus 5। so what is its waiting time, its waiting time is 2। so with the help of this Gantt chart we are able to find the waiting time of each and every process। now if we want to calculate the average waiting time, what is the average waiting time, Average waiting time is now 9 for process P1. We will sum up all the waiting times, and it will be divided by the number of processes. So there are 4 processes. Average, we have calculated the individual waiting time of each process, and now we will do the addition of these waiting processes, like 9 plus 1 plus 0 plus 2 and divided by 4. So average waiting time is 3 in this case. So if we now compare both the cases, that is preemptive and non-preemptive. See, in non-preemptive scheduling, average waiting time is 4, and in preemptive scheduling, average waiting time is 3. So by this we conclude that average waiting time in terms of preemptive algorithm, preemptive shortest job first algorithm, is less as compared to non-preemptive shortest job first algorithm. And one more thing is there, with the help of these numericals, we are it is clear to us that in नॉन प्रिमिटिव सी आपको P1 से ही क्लियर हो जाएगा कि इट इज अ नॉन प्रिमिटिव, सीपीयू से प्रोसेस बाहर नहीं निकला. And along with these algorithms, you are able to understand the words primitive and non primitive. And next, with this example, you are able to see what is primitive here. Primitive stands for कि P1 अभी चल रहा था सीपीयू में, लेकिन P2 shortest time वाला आया process, तो उसको मिल गया. That is called primitive. And one more thing, we have compared P2 with the remaining time of P1. So that's why this algorithm is also known as shortest. Its other name is primitive SJF, others name is shortest remaining time first, because we have compared the coming processes with the remaining time of currently executing processes. Please note students, this is also called primitive SJF, is also called shortest remaining time first, and by this numerical you are able to see this why it is called shortest remaining time first. So these are the examples of shortest job first. So we have till now we have discussed the algorithms first come first serve and shortest job first, and in shortest job first we have discussed about the primitive shortest job first and non primitive shortest job first. So today our next algorithm is shortest remaining time first. Next algorithm is shortest remaining time first. So what is priority algorithm? Sorry, our next algorithm is priority algorithm. What is priority algorithm? Third algorithm. We have discussed first come first serve. We have discussed shortest job first. Now we will discuss about the priority algorithm. Priority algorithm is when the scheduling is done on the priority. A number is always assigned to every process. That number is called priority of the process. That number is called priority. Like in shortest job first में आपने देखा जो priority है process की, वो CPU bus time की inverse थी. जिसका shortest bus time था उसको सबसे ज्यादा priority मिल रही थी, और वो सबसे पहले क्या हो रहा था, CPU में run हो रहा था. And the larger the bus time, the lower will be the priority. But हमेशा ये नहीं रहता. प्रायोरिटी एल्गोरिदम में क्या रहता है, हर नंबर के साथ एक हर प्रोसेस के साथ एक नंबर एसोसिएट होता है, एंड दैट नंबर डिसाइड्स द प्रायोरिटी ऑफ द प्रोसेस, एंड दैट नंबर विल बी एलोकेटेड इंटरनली और एक्सटर्नली, डिपेंड्स ऑन द कंप्यूटर, डिपेंड्स ऑन द सिस्टम. Sometimes it can be set internally and sometimes it can be set externally, but yes, it is sure that scheduling can be done with the on the basis of priority of the process, which is very very important part of this algorithm, कि on the basis of that integer, that priority, हम scheduling करेंगे, CPU allocation हो. ठीक है. तो अगर जिन प्रोसेसेस की सेम प्रायोरिटी है, नाउ अब क्वेश्चन आता है माइंड में कि अगर दो प्रोसेसेस हैं और उनकी प्रायोरिटी सेम है, तो कौन पहले एग्जीक्यूट करेगा? सेम फर्स्ट कम फर्स्ट सर्व की तरह, द प्रोसेस विच कम्स फर्स्ट विल बी एग्जीक्यूटेड फर्स्ट. So priority algorithm depends on the priority, and one more thing is there, that इंटीजर के जो इनवर्स रहता है, जो लोएस्ट इंटीजर रहेगा उसकी हाईएस्ट प्रायोरिटी रहेगी, एंड द हाईएस्ट इंटीजर इज हैविंग अ लोएस्ट प्रायोरिटी. सो here we must keep in mind that if any process has the number 1 associated with it, priority number, so that process is having highest priority. So the CPU is allocated to the process with the highest priority, smallest integer उसको allocate किया जाता है. So this is the priority now. Just like SJF, shortest of first, priority algorithm is also of two types. One is primitive and other is non-primitive. So primitive priority algorithm is same. If new process arrived at the ready queue have a higher priority than the currently running process. अगर कोई नया process आया जिसकी priority higher है currently running process से, तो CPU क्या हो जाएगा? Preempt हो जाएगा. मतलब कि करंट रनिंग प्रोसेस की जो एग्जीक्यूशन है वो स्टॉप हो जाएगी और जो इनकमिंग वाला नया हायर प्रायोरिटी प्रोसेस है उसको सीपीयू एलोकेट हो जाएगा. दिस इज कॉल्ड प्रिमिटिव. सिंपल, इन सिंपल वर्ड्स, प्रिमिटिव मींस अगर प्रोसेस रन हो रहा है और अगर क्यू में नया प्रोसेस आया जिसकी प्रायोरिटी क्या है, रनिंग प्रोसेस से हायर है, तो रनिंग वाला प्रोसेस सीपीयू से हट जाएगा, प्रिम्प्ट हो जाएगा, शिफ्ट हो जाएगा क्यू में, और जो नया प्रोसेस है हायर प्रायोरिटी वाला वो रन होने लग जाएगा. एंड नेक्स्ट इज नॉन प्रिमिटिव प्रायोरिटी शेड्यूलिंग. नो, इन केस ऑफ नॉन प्रिमिटिव प्रायोरिटी शेड्यूलिंग, अगर नया प्रोसेस अराइव हुआ विद हायर प्रायोरिटी देन द करंट रनिंग प्रोसेस, तो जो नया प्रोसेस होगा उसको क्यू की हेड पे रख दिया जाएगा, बट जो रन हो रहा होगा प्रोसेस उसको प्रिम्प्ट नहीं किया जाएगा, उसको सीपीयू से नहीं हटाया जाएगा. दैट इज कॉल्ड नॉन प्रिमिटिव एल्गोरिथम. So this is all about the introduction of priority algorithm, and in our next lecture we will discuss about the problem which comes in priority algorithm, that is starvation problem, and its solution is aging. We will also discuss this aging and starvation with the help of example, and we will also do the numerical problems of primitive and non-primitive CPU scheduling algorithm, priority scheduling algorithm. So for this lecture, I hope every concepts which we have discussed in this lecture have been clear to all of you. So thank you and take care.